Math 3, Unit 10, Section C, which goes along with Worksheet 3. Today we're building on what we learned yesterday. So some of this you already know. Starting with standard position, okay? So remember that standard position, you start at your initial side. You draw your arrow around to your terminal side, okay? That is the standard position of an angle. This is your initial side, terminal side. Okay. The measure of an angle is positive when the rotation from the initial side is going counterclockwise, so going to the left, that is positive. And when you go clockwise, going down, that is a negative angle. Okay. Something new today is coterminal angles. Coterminal angles are if they have the same terminal side. So if you look at this picture here, if 135 degrees was my initial angle, okay, in standard form, 135 degrees, a coterminal angle would be going from the opposite direction, negative 225 degrees. So they each have the same terminal side, but they're different angles, okay? How could I find, if I only had the 135 degrees, what would I do to find the coterminal angle? Subtract from 360. Good. Okay, so we're going to go ahead and skip down here to our first examples. And so for each of the following, we're going to, sketch the angle in standard position. So let's start by doing that on A first. So we have 150 degrees. Where will 150 degrees, what quadrant will that end in? Very good. So we're going to draw our terminal side, and then we're going to draw our angle, and that is 150 degrees. So we've sketched that angle. Okay, 2 said identify the quadrant, and you already did that, which was quadrant 2. Now 3 asks us to identify one positive coterminal angle and one negative coterminal angle. So I'm going to go ahead right here, and we're going to put positive and negative. So for this problem, I feel like the negative one is probably the easier one to find. And so what would I do in order to find my negative coterminal angle? Good. So 360 minus 150, and when you do that, you get 210 degrees, but it's not going to be 210 degrees, it's going to be negative 210 degrees. And so you do not need to mark this on yours, but I'm just going to show you these kind of in different colors. And so the negative 210 degrees would be starting here, going the opposite direction, and that makes a coterminal angle, meaning that they are both terminating at the same point, okay? The other one we need is another positive coterminal angle. And so if this is ending at 150, what would I need to do in order to get an additional coterminal angle for the positive side? So could I, and I'm going to do this in yellow, and again, you don't have to mark this on your grid here, but if I want to end up at 150, but I'm going to go the positive direction, if I do a whole 360 and then go back around, would that give me the same terminal side? So what would I do? How could I figure out what that is? If I'm doing a whole 360 and then going back to the 150 mark. Yeah, so we would just take 360, because we want a whole 360 degrees plus 150. And we add that together, and we get 510 degrees. And so there is obviously like an infinite amount of values that you could end up getting for coterminal angles. Make sense? Do you want to ask me any questions? So this would be a positive answer, and that is a negative answer. So those are both coterminal angles. So we always want to end up at this point, okay? And so when you're finding coterminal angles, There's sometimes maybe the original angle is going to be greater than 360, like for instance on B. And so we could subtract out 360 to get the same terminal side. So it kind of depends on what you're starting with. But you could always, if you have positives, we normally would add 360 to it to get another positive. If you have something over 360, you could subtract 360 to get the same terminating side. Does that make sense? Okay. Danny, did you have a question?
Like for the 360 minus 150, you just make that negative?
Well, because in order to get here, we're going that clockwise. And so clockwise, negative 210 will get you to that same spot. And so remember they wanted a positive and a negative. And so in order to get to the same spot, I took the 360 and subtracted 150 because I know 150 gave me that part. And so that means that whatever those two together make the whole circle. So, but I know that this one I'm going down, so that's why I gave it the negative. Okay? Anybody else have questions? Okay, so let's try the next one together. So we first need to draw it. Negative 380 degrees. What quadrant will that end up in? 4 is correct. Okay? So remember negative 360 is a whole circle. And so we would go around and that makes 360. And then we're going to have to go an additional 20 in order to make negative 380. So that is negative 380 degrees. Okay, so question 2 now has been answered because we've identified that it's in quadrant 4. Okay, and then 3, we need a positive coterminal angle and also a negative coterminal angle. This one could be slightly different just because it's greater than 360. So we could do the values that are less than 360. Does that make sense what I'm saying? Okay, I'm going to give you guys about a minute to try to figure out what a positive and negative coterminal angle would be. You can talk in your groups about it and then we'll come back together and see if we got it figured out. I'm going to give you a hint for the negative. I just put a little red arrow there to give you an idea of what you could do for the negative coterminal angle. Okay, so who thinks they have the negative coterminal angle? Joseph, what is it? You are super close. You just forgot the negative sign in front. It is negative. Negative 20. I was asking for the negative first. Okay, so negative 20 degrees is a negative coterminal angle. So we know that 360 is the whole thing. And so if you took 380 minus 360, we get 20 degrees. And so this is going down an additional 20 degrees, which is how I could just go negative 20 degrees for my coterminal angle. Okay, now for the positive, and I'm going to do this in my yellow. From here all the way to here, what would be that value? So we know this red portion is how much? 20, and so if you just take 20 from 360, you get 340. So a positive coterminal angle is 340 degrees. And again, I was saying that I would take 360 minus 20, and I get 340 for my positive. So starting here and going around, I can hit that same terminating side, okay, for 340 degrees. Do you guys want to ask me any questions? Yesterday was more difficult? Oh, because it's... I think that yesterday was like everything was new, and today we're like kind of redoing some of it and adding a little more. That's why. Because now you have some background knowledge. Okay. Are we good? Can I move this or? Okay. Next page. Okay, so in a 360 degree angle, a point 1 unit from the origin on the terminal ray makes one full rotation. So what they're saying is this is 1 unit, that 1 unit's going all the way around. Okay? This is called a unit circle. Okay? And so a unit circle has a radius of 1 unit and its center at the origin of a coordinate plane. Okay? And so that means that anything coming off of here, any line, that will end up making 1 unit. So all of the hypotenuses, when you're drawing them out, they're going to be 1 unit. Okay? So we've already talked about a reference angle, and that is when you're finding what the angle is to the x-axis, right? Once it ends to the x-axis. You also need to always remember your quadrants, and that they go 1, 2, 3, 4, correct? Another thing that you want to always remember is that going to the right is positive, left is negative, up is positive, down is negative. Okay, so this is just like yesterday's, okay? These examples, we want to sketch the angle in standard position, state the quadrant, and then give the reference angle. Okay, so for number, or letter C, 230 degrees is going to end up in which quadrant? 3. In fact, I'm going to go back up here in case you've forgotten. Remember, this would be 0 degrees. Going up here, that's 90 degrees, 180 degrees, and this is 270 degrees, and then it goes back up to 360. And you could keep going around and adding by 90s. But 230 is in between 180 and 270 degrees. So we draw our terminating side there, and so this goes around to 230 degrees. Okay, quadrant 3, and my reference angle. Okay, and so remember that your reference angle is always positive, so you don't have to worry about any negatives. It always goes up to the x-axis. Okay, what will be my reference angle there? The correct answer is 50 degrees. And where did that come from? Good, I subtracted 180. 230 minus 180 is 50. Okay? Always positive. Do we have any questions there? Okay, D. This reference angle we have to find, but first we're going to sketch it in standard form. Negative 500 degrees. First of all, because it's negative 500, it's telling me 2 things. Number 1, it's going to go which direction? Down or clockwise. And then because it's greater than 360, we know it's going to make 1 whole loop. Correct? How can I figure out where it's going to stop? Good. 500 minus 360 Very good. Gives me 140 left over. Okay, now this is where you have to think because we're going backwards, right? And so let's go ahead and just start drawing it. So 360, and I'm right here, and I still need to go 140. Where am I going to end up? Very good. Quadrant 3 is correct. And so we're going to write that as negative 500 degrees. That is in quadrant 3. And now we need to find our reference angle. So here would be my reference angle because we always go up to the x-axis. So how can I figure out what this portion right there is? That's exactly what I would do, is 180 minus 140 leaves you with 40 degrees. We know that, and I'm just going to kind of highlight this in yellow here, from here to here, we knew was 140, correct? And so for your reference angle, we just need to figure out, well, how much more there will get you up to the x-axis, which is just an additional 40 degrees. Okay, do we have any questions? Yes. For C, how do I know whether to subtract or okay. The reason why I subtracted 360 here originally is because I needed to figure out where I'm going to end, where my terminating angle is going to end. And so because 500 is greater than 360, I subtracted 360 to find out what's left. So I knew I was going to do one whole loop, which is 360, and I was just figuring out how much further I'm going. This one is less than 360. So on this one, I'm just going until it stops. Is that what you're asking? And then it just kind of depends what you're going to do. So on this one, to find my reference angle, since I went all the way here to 230, I'm trying to find this angle right here, correct? And so I subtracted out 180 because it's like I'm taking this whole portion off and just getting that piece. And so when I take off a half circle, I'm taking out 180. All right? Any other questions? Okay. So again, we're looking at our unit circle. This is also something a little bit new that we're going to apply here. So we already talked about this is a unit circle. It's going 1 unit each direction. Each of these coming off is 1 unit, okay? Now, what is new is that cosine, sometimes we're going to end up on like the 90-degree mark or the 0 mark or the 180 mark. And we have to figure out what sine, cosine, and tangent are at those points. And so cosine is always going to be dealing with the x, okay? Where sine is always going to be dealing with the y. And tangent is y over x. This is something you're going to end up wanting to memorize. Okay, so again, I'm just going to write it right here. Cosine is dealing with x. Sine is dealing with y. And tangent is y over x. You know how slope is your y over x? That's how I just remember tangent's kind of the same as my slope equation, y over x. Okay? Remembering that cosine is x and sine is y. X comes first before y, correct? C is before S in the alphabet. So cosine is with x, sine is with y. That's how I personally remember it. You might have a better idea. If you do, feel free to share it, but I'm just telling you that's how I remember them. Okay. So because of this information, we can always find exact values for sine, cosine, and tangent for angles that are on your unit circle. Okay, so for each of these problems, we're going to first sketch the angle in standard position. So let's do that. We are hopefully getting better at this. So where will negative 45 degrees be? Quadrant 4, right? Because we're going clockwise, we're going down. I'm going to make this actually a little bit bigger. Okay, and so this right here, that is saying that this is negative 45 degrees. Is everybody good with that? Okay. So the next thing is that we need to find the reference angle. So on this one, my reference angle is going to be what? 45 degrees. Remember that your reference angle is always positive, okay? And so when we're saying that the reference angle is 45, we are talking about this angle right here. So I'm going to go ahead and write 45 degrees right there. So if that is 45 degrees, what is this angle down here? Also 45 degrees. Okay, ask me questions as I do things. So far, so good? Yes? Okay. So the next thing they've asked us to do is state the quadrant, which, no, they didn't. Okay, but we know it's in quadrant 4. And it says identify sine, cosine, and tangent ratios for each angle. Well, remember how we know all the numbers that match up with the 45, 45, 90? Okay, what number goes with each of my 45s? 1 and 1. So across from each of my 45 degrees are 1. Do you guys remember what's across from the 90? Root 2 is correct. Okay, so in order, let's go ahead and write down sine first. And I've actually forgotten something on here. Does anybody know what I've forgotten? Is this a positive 1? Is it going to the positive side? Yes, it is positive 1. But this one is going down, so therefore it should be negative. And all of your hypotenuses will always be positive. So the only thing we're missing is that should be a negative 1. Okay. Sine is what? Opposite over hypotenuse. So we're always dealing with our reference angle right there. Okay, so if this is opposite over hypotenuse, what is opposite of that 45 degrees? The number. Negative 1. And what is my hypotenuse? Root 2. Very good. You can't have a root in the denominator. I'm going to show you how we get rid of the root in the denominator, but we're going to start skipping that step because hopefully you're going to see there's always a pattern, okay? So to get rid of root 2 in the denominator, I multiply by root 2 to the top and bottom, and it ends up becoming negative root 2 over 2, correct? Because these two root 2's make a 2. This root 2 doesn't have anything it matches with, but there's a negative 1, so it's negative root 2 over 2. Okay, cosine of 45 degrees. Or, sorry, cosine of negative 45 degrees. Cosine is what? Adjacent over hypotenuse. And so from this 45 degrees, what is adjacent to it? 1 over the hypotenuse, which is root 2. Without doing any work, it becomes root 2 over 2. Are we all okay with that? Troy, you getting this?
Yeah.
Okay. Last one we have is tangent of negative 45 degrees. And tangent is what? Opposite over adjacent. And so what is opposite there? Negative 1 over adjacent, which is 1. And that reduces to just be negative 1. Okay, ask me questions. Right. And so if you just have a negative number that's less than 90, the reference angle and your original angle are the same. And same with going up. If that number is less than 90, they both are the same. Okay? All right, F. So on this one, we're going to draw 210 degrees. Where is 210 degrees going to terminate? Quadrant 3, very good. So let's draw this. So we go around, we end at quadrant 3, that's 210 degrees. The first thing we always need to figure out, because this is where all of our information is going to be coming from, is our reference angle. Okay, what will be my reference angle for this problem? 30 is correct. How do they figure out the 30? Good. 210 minus 180. We know this whole portion is 180, so to find out this portion right there, we just subtracted it, and this becomes 30 degrees. So again, you could write this out. I'm going to put it right here. 210 minus 180 gave me my 30 degrees. If this is 30 degrees, what is that bottom angle right there? Very good, 60 degrees. Okay, and we have numbers for our 30, 60, 90 triangle as well. Okay, across from the 30 is your 1. Across from the 60 is your root 3. And across from your 90 is your 2. Now, I'm going to tell you guys how I remember that root 3 goes with 30, 60, 90, and root 2 goes with 45, 45, 90. And that is, if you count, you have 1, 2, 3. So all 1, 2, and 3 go with one triangle. On the other one, it's 1 and 2. See how it goes in order? So you're not going to have a 1 and a 3 because it would be missing part of that order. Got it. She's here. G, I have a note for you. Okay. Also, we talked about this yesterday, but remember that they go in order. 1 is the smallest number. It goes with the smallest angle. 60 is the next largest number, and it goes with the root 3. Root 3 is really 1.7. And 90 is your largest angle, so it goes with the largest number, which is 2. Okay? So 1, 2, 3 go together, and 1 and 2 go together. Each of them have a root. Okay. So now we have to do our sine, cosine, tangent. So we have sine of 210 degrees. So you're always finding the sine of your original degree that they gave you, even though we're really only looking at this portion right here. Okay? And so for sine of 210 degrees, what will that be? And again, you're always, this is your starting point. It's always at your reference angle. Okay, so opposite is 1 over hypotenuse, which is 2, but that is incorrect. Why? What did I forget? Negatives. Okay, this is going down, right? So that is actually a negative 1. And root 3 is what? Is that negative or positive? Negative. Because remember, going to the left is negative. So right is positive, left is negative. Up is positive, down is negative. So this root 3 is going negative, as is the 1 is going negative. Okay, so on this one, we just need to add in the negative 1. Okay, cosine of 210 degrees will be what? What's the cosine? Good, negative root 3 over 2. And then last we have tangent of 210 degrees, which will be negative 1 over negative root 3. And what does that reduce to? Positive root 3 over 3. Because two negatives make a positive. And then because of the root 3 in the denominator, we've multiplied by a root 3 to both the top and the bottom. Thanks. Okay, questions? All right. Letter G. We're going to draw our coordinate plane there again. And where is negative 90 degrees going to go? It's in between quadrant 3 and quadrant 4, correct? So I'm going to just put a point there for myself, and I'm going to draw my angle, and that's negative 90 degrees. There is no reference angle for any of the points that end up on your axes, okay? And so we're going to write no reference angle. And this goes back to what we talked about at the beginning of this page, where cosines x, sines y, tangent is y over x. So dealing with our unit circle, this point right here is at what ordered pair as a unit? It's going 0 on the x and down 1 on the y, which would make it a -1. Okay, so this point here is at 0, -1. Because remember how we talked about that we're dealing with a unit circle, everything is 1 unit. And then that your cosine is dealing with the x, sine is dealing with the y, and tangent's y over x. So if you end up on one of these points, it's going to be 0 and 1 in some sort of positive negative order, okay? So now if we go to do our sine, cosine, and tangent. So sine of negative 90 degrees. We can. So sine, going back, what is sine dealing with? Sine is dealing with your y. And you could even think of this as y over 1, or all of your hypotenuses are going to be 1 on your unit circle. Okay? And so what is the y value here for this ordered pair? Good. So you end up with -1 over 1, which reduces to be -1. Our hypotenuse is going to be 1 for all of them. Remember? Okay? Because anything that's being drawn out on here will end up being 1. Or if it makes more sense to think of y as being, you could put y as a fraction by putting it over 1. Okay? Cosine will be what? Cosine of negative 90 degrees. Cosine is dealing with the x. Okay? And my x value is 0, and 0 over 1 is just 0. Tangent of negative 90 degrees, is dealing with y over x. And so my y value is what? -1 over x, which is 0, but you can't have 0 in the denominator, and so therefore it will be undefined. So tangent ends up being undefined. Okay, questions on this one before we move on to the next example? Okay, so we're moving on to H. We start by drawing it in standard form. 405 degrees though. That's going to make a full circle and then come back around to what? Very good, to quadrant 1. And if you want to figure out exactly where it's going to be, we can take 405 minus 360, because that would be my whole circle, and I'm left with how much? 45. Very good. So we know we're going to end up here. So I'm going to make this, because I know I'm going to end up I did not do something right. Hold on. I started on my arrow instead. Sorry. Let's try this again. Okay. I'm going to go like this. So we have it like this, and then we end up right there. Okay, and that we're going to label as 405 degrees. Okay, we're going to draw our reference angle. And what will my reference angle be? Very good. My reference angle ends up being 45 degrees. And that one was pretty easy because we did the 360, and then this ends up being my reference angle, which is 45 degrees. If my reference angle is 45 degrees, this angle here on top is also very good. Okay, now we need to label our triangle. What numbers go across from the 45s? Good. And then my hypotenuse will be root 2. Very nicely done. Okay, will any of those have negative values? No, because they're both going positive directions, correct? Okay, so we have sine of 405 degrees. We know that sine is going to be what? Opposite over hypotenuse. Again, your reference angle, that's the angle you're talking about. So what is my sine from there? Opposite is 1 over hypotenuse is root 2, but that will end up becoming root 2 over 2. Cosine of 405 degrees will be what? 1 over root 2 again, which ends up becoming root 2 over 2. And then we have tangent of 405 degrees, which will be 1 over 1, which just reduces to 1. Do we have any questions? Is this starting to feel more natural? A little? Thanks. Okay. Last one. For time's sake, we're going to do this together. Okay, so standard form. 540 degrees. Where will it end up? At 180. If you take 540 degrees and you subtract 180 degrees, you end up with, or not 180 degrees, sorry. Subtract 360, we get 180. So we're starting here. We do a whole 360, and then we end up going all the way to the 180 mark. That is 540 degrees. So because we're ending here on a line, we're going to have to use our special values for sine, cosine, tangent on our unit circle, okay? And so this point right here is at what? -1, 0. And I also like to label those as x and y to help me out when I'm doing my sine, cosine, and tangent. So sine of 540 degrees is what? We know that sine is y. So it'll be 0 over 1, which ends up being 0. Okay, cosine of 540 degrees. Cosine is dealing with my x, and so that will be -1 over 1, which reduces to be -1. And then we have tangent of 540 degrees, which is y over x, and we have 0 over -1, which is 0. Do we have questions? Okay, last page. And seniors, if you end up having to leave during notes, just leave, but I'm going to keep going just so this is all in one video, okay? But honestly, before we do these examples, I want to give you some important things that you need to remember, okay? So in terms of trig functions, okay, I want you to think about these in terms of positives and negatives, and we're going to do some little trig function graphs. Okay, so this is like the bottom half of your paper here. So we know that sine is dealing with y, correct? So on a coordinate plane, where is y positive? Which quadrants is y positive in? So this is your y-axis, correct? So we know that going right is positive, left is negative, up is positive, down is negative. So y, the positive portion of y, is in quadrants 1 and 2, where it's negative in 3 and 4. And this is going to be helpful in everything that we do. Okay, cosine is dealing with our x values. So on a coordinate plane, where is x positive? Which quadrants? Good. So 1 and 4, it's positive, and 2 and 3, it is negative. Now, tangent is dealing with y over x. Where is the only place that we haven't had a positive yet? 3, right? This is positive and this is positive. The reason why this is positive, because here you're going to get a negative over a negative. Does that make sense? And so 2 negatives make a positive. And so tangent is positive in both of those quadrants, which means it's going to be negative in each of these. Okay. They're supposed to make an announcement for seniors, so you're good, but. Okay, so one more thing. Cosine is x, sine is y, and tangent is y over x. The other things that I want you to remember, and then seniors, I'll let you, well, I'd like you to see these last examples if you can, but 30, 60, 90 triangles. Remember that 1 goes with 30, root 3 goes with 60, and 2 goes with 90. In your 45, 90 triangles, 1 goes with 45, 1 goes with 45, and root 2 goes with 90. Okay, all of these things are things that you're going to want to remember. So real quick, back to example J. Does everybody have all this? Okay, I'll wait for a minute here. If you look on example J, it's asking you which quadrants could it lie in so that those equations are true. So I'm going to move this down here for a minute. So cosine, you see how it's saying is cosine is negative? So if I draw this graph, we know that cosine is dealing with x, right? So where is x negative? And 2 and 3, cosine's negative, right? Because we're dealing with the x's. So that means that this answer is quadrants 2 and quadrants 3. That is the only time that cosine could end up being negative. So it could end up in quadrant 2 or quadrant 3. Okay, over here, this is dealing with tangent. We know that tangent is y over x. Okay, so for tangent, do you remember how this, where is tangent going to be positive? The top one and the bottom left. So, and right here it'll be negative. And the reason why it's positive here is because it goes negative, negative, right? And so that means my answer is quadrant 1 and quadrant 3. Okay? And then I was going to do one with sine really quick. So let's just say we're going to add L. Sine of theta equals negative 1/2. Okay, so where is sine is dealing with y? Where is y negative? Very good. So that answer would be quadrant 3 and quadrant 4. Okay, do we have any questions?